In this video, we're going to take a look at some examples of solving quadratic equations. Here we have our standard form of quadratic equations, 0 equals ax squared plus bx plus c, where a, b, and c are just integers. And a lot of times this is where we want to start. Well, we'll see some different ways to get around it here. So first we've got the square root method. So anytime that we have an equation that just has an x squared and doesn't have an x term at all, this is a great time to go ahead and use the square root method. So to do that, we want to take our equation 4x squared equals 25. And let's first of all get that x squared all by itself. Let's divide by 4. Leave it as a fraction. It's much easier to deal with. And then we want to go ahead and let's square root both sides. Remember that every number has 2 square roots. So we're going to get the square root of 25 is 5, square root of 4 is 2. Well, we get 2 answers, positive and a negative. We can call that plus minus. Or we can write it as x equals 5 halves, or x equals negative 5 halves. Alright, usually this answer right here is just fine with the plus minus. Alright, so how about if we have a little different situation here? Here we have a binomial squared. Well, we could go ahead and multiply that out, but that's going to get pretty ugly. So let's try getting that squared all by itself. So let's take our, I'm going to copy this down, 3x plus 4 squared equals 8. And let's divide that by 3. And then we've got x plus 4 squared equals 8 thirds. Remember, the challenge is just to get rid of this squared. That's our first challenge there. And then once that's gone, we can treat it just like a linear equation. So, okay, let's go ahead and square root both sides. And we get an x plus 4 over here. And on this side, we're going to get a plus minus square root of 8 thirds. How we're going to deal with that? Well, how about let's call it the square root of 8 over the square root of 3 for right now. Okay, we want to rationalize that denominator. So let's go ahead and multiply by the square root of 3 over the square root of 3. And so we get x plus 4 equals, on top, 8 times 3 is 24. So we have plus or minus the square root of 24 all over 3. We've got a rationalized denominator now. And we just need to clean this up. 4 goes into here 6 times. 4 times 6, of course. And so we have x plus 4 equals the square root of 6. And the square root of 4 is going to become 2 over 3. Or we have x plus 4. You know what, let's go ahead and leave it as the same here. Let's go and do our plus minus. That's fine here. Okay, and then what we need to do is we need to go ahead and subtract 4 from both sides. In the end, we have x equals plus or minus 2 square root of 6 over 3 minus 4. If we wanted to clean that up a little bit, we could say make this minus 4 into 12 thirds, and we can have x equals 12 plus or minus 2 square root of 6 all over 3. Let's squeeze it in there. Alright. One more here. Another square root method. It looks a little more complicated, but notice we just have y squareds here. We have no y terms. And so let's take our 2y squared minus 8 equals 6 minus 2y squared. And let's go ahead and add 2y to both sides. 2y squared, that is. And let's add 8 to both sides. Divide by 4. And we get y squared equals 14 fourths. Next step, we want to square root. Every time we square root, we're going to get 2 answers. So this gives us y equals plus or minus the square root of 14 over, and the square root of 4 on the bottom is 2. We can't do much with the square root of 14 because there is no perfect square that goes into 14. So we're done. Don't forget your plus or minus, and that is the square root method.